So, okay, good afternoon. So, to the last lecture, we have seen the design of compression member, single angle and double angle compression member procedure we have seen. So, the next part of the unit number 4. So, first part is the compression member and second part of unit number 4 is column. So, now we have to design the column. So compression member, it means single angle strut and double angle strut we have designed. Now in column, we are designing the I section and channel section. So before that, what is column? So at the start of this chapter, unit number 4, we have seen the what is compression member, what is strut, what is column. So actually column is the vertical member. Column is the vertical member which uh, carries a compressive load and which supports to the floor or girder. That definition we have seen. Actually, what is column? The column is a vertical compression member. Vertical compression member which supports the floor and girders. Floor and girders. So where girders are there in bridges, there are girders are there, long beams we are calling as the girders, and floor it means our regular horizontal roof. It may be roof covering AC seat, GI seat, or truss. So giving support to the truss we called as a floor, and girders are in the various types of bridges. It may be railway bridge or it may be road bridge. For these bridges, horizontal long span girders are there, that are the girders supporting on the column. So column is nothing but the vertical compression member which uh, supports floor and girder. So generally columns are subjected to heavy load. These columns are subjected to heavy loads. It means, so whole structures loads coming on the columns. So it's subjected to heavy loads. Means whatever all superstructure is there, that superstructure's total whole load is coming on the column, and finally column transmitting load to the ground or foundation. So the heavy load is there. So for this we are using generally simple section and I section. So the sections used for column, sections used for columns, that are the simple section and built up section. Simple section and built up section. So these two sections we are using generally for the design of column. So initially we will design this simple section and then built up section. So we will ask the examples on the simple section and built up section in examination. So we will see the first simple section. So in this for this simple section and built up section, generally we are designing, or we are using uh, I section and channel section. I section and channel section. So for the designing this column, we are generally using the I section and channel section. So first we will see the design of simple section. So before that, we will see what is simple section and what is built up section. So generally simple section is nothing but single I section or channel section. What I'm telling, single I section or single channel section we are using or we are designing as a column, so we called as a simple section. Simple is nothing but, simple section is nothing but single I section or single channel section. Means one I section and or one channel section. If we are using, then we are calling as a simple column. So called as a, so single I section or single channel used as column called as simple section. What is simple section? Single I section or single channel section used as a column, then we are called as this a simple section. It means one channel or one I section. एक channel वापरायचा किंवा एकच I section वापरायचा. जसं की आपण सिंगल अँगल आणि डबल अँगल बघितलं, एकच अँगल सेक्शन वापरला किंवा डबल अँगल सेक्शन बॅक टू बॅक वापरला, त्याला आपण काय म्हणतोय, सिंगल अँगल आणि डबल अँगल. सिमिलरली इथं काय म्हणतोय आपण, सिंपल आणि बिल्टअप. कॉलम मध्ये काय म्हणतोय, सिंगल आणि डबल म्हणण्याऐवजी इथं काय म्हणतोय आपण, सिंपल आणि बिल्टअप. सो सिंपल इज नथिंग बट सिंगल आय सेक्शन और सिंगल चॅनल सेक्शन इफ वी आर युझिंग ॲज अ कॉलम, देन वी कॉल्ड ॲज अ सिंपल सेक्शन. And when we called as a built up section, two I sections or two channel sections, two or more, here we can say two or more I sections or two or more channels used as column, we called as a built up section. Are you getting? So the basic difference between this simple section and built up section, are you getting? If we use single angle or single channel, single I section or single channel section, then it section called as a simple section. If we use two or more I section or two or more channel section as a column, the section or the section is called as the built up section. Are you getting? लक्षात आलं का? दोन टाइपचे आपण दोन टाइपचे कॉलम बघणार आहे किंवा दोन सेक्शन असणार आहेत, सिंपल सेक्शन आणि बिल्टअप सेक्शन. सिंपल म्हणजे एकच आय सेक्शन किंवा एकच चॅनल सेक्शन जर वापरला तर त्याला आपण सिंपल सेक्शन म्हणणार. आणि जर दोन वापरले आय सेक्शन, तीन वापरले, चार वापरले आय सेक्शन, तर त्याला आपण बिल्टअप सेक्शन म्हणणार. दोन्हीची डिझाईन प्रोसिजर वेगळी आहे आणि आपल्याला कॉलम डिझाईन करायचं आहे. सो वी विल सी फर्स्ट नाव, वी विल डिझाईन फर्स्ट नाव. This is over. You are writing simultaneously. Okay. So now, first we will design the simple column. So write down the procedure for the design of simple column. Design of simple column. So theory behind this we have seen at the start of the chapter. It means effective length, slenderness ratio, FCD, PD, that everything we have learned in the at the start of the chapter, and some of the examples we have seen on the compression member also. So theory of this for this column we have seen at the early start of this chapter. So here directly we will start the design procedure or design of the simple section, or we call as a simple column. Simple section or simple column. So we'll write first procedure, and then we will solve the examples. Okay. So procedure, design procedure we will see first. Design of simple section first or simple column. So write down everyone step number 1. Step 1. Calculate factored calculate factored compressive load. Compressive, or we call as also compressive or axial. We are calling as factored or axial. So that we know, we have seen last time. F is equal to, how to calculate factored load, 1.5 into service load or working load. How to calculate factored load? So factored load we are calculating multiplying by 1.5 to service load and or working load. So this is the step number 1. Then step number 2. Step number 2 is calculate the required area. Calculate the required area. So for this factored load, we have to calculate the required area. And for this area, we are selecting the section. So required area, A required is equal to F divided by FCD. Same formula for compression member. For compression member, stud member, single and double angle, we have seen this formula, F divided by FCD. In type 3 for compression member. So here we have to assume the value of FCD. So for compression member, how much value of FCD we have assumed? Anyone can tell me the range for FCD? How much we have assumed for compression member? जेवण झालं, झोप लागली काय?
90 to 120.
Okay, 90 to 120 we have assumed. So range is 90 to 120. So here we are assuming 120 Newton per mm square to 180 Newton per mm square. Newton per mm square, because actually the column carries heavy loads. The column, we are all the familiar with the column. If we see the any column, the whole above structures load coming on the column, and then again column transferring the load to the ground. So column is a very important member, because the above superstructure load is whole load coming on the column. If any multi-story building, 8-story, 9-story, 10-story, total load is coming on the column. So column is a very important member. So for that we have to consider the design compressive stress is 120 to 180 mm, between this range. For simple column, we are assuming generally less than 150. This is the simple column. Built up column, we are assuming after the 150, 160 like this. So for simple column, generally we are assuming 120, 130, 140 up. Okay. So this is the step number 2. Calculate the required area. Area required is equal to F divided by FCD, and FCD we have to assume here 120 Newton per mm square to 180 Newton per mm square. Are you getting? And for compression member, strut member, single angle and double angle, we have assumed here 90 to 120. Because column I section and channel section will carry more load as compared to angle. आतापर्यंत आपण काय बघितले, अँगलची कॉम्प्रेसिव्ह स्ट्रेंथ बघितली सिंगल अँगल आणि डबल अँगल प्रोसिजर मध्ये. हियर वी आर using the I section and channel section. So I section and channel section having more load carrying capacity than this single angle and double angle. So step number 2 is over. Now step number 3. So step number 3 is nothing but select suitable I section or channel section, whatever given in the problem statement. I section or channel section from steel table and find the properties. So here properties are required, that is area, then width of flange, BF is nothing but width of flange, then TF, hello, पाठवली की. मग आता मगाशी देतो म्हणतो तो तुम्ही द्या म्हटलं तर घेतली नाही. आता मी लेक्चरला आहे. लिमकर सर म्हणत नव्हतोय मगाशीच घ्या. बर. Okay, so we have to find the properties like area, then width of flange, then thickness of flange, then thickness of wave TW, then R minimum, and then if required H1. So these all properties are given in the steel table for this particular section, particular I section and channel section. These all properties are given, and these properties are required for next calculation purpose. So in step number 3, we have to select the section for this area required, and we have to find these properties: gross area, BF width of flange, TF thickness of flange, TW thickness of wave, R minimum, and H1. So these we have to find out. And H also we have to find out. H is the overall depth of the section. H also we have to find out. Okay, so this is related to step number 3. Now step number 4. Okay. Now, just minute. Here, step number 4 is select the buckling class. Select the buckling class. So go to the page number 44, IS 800 2007. Step number 4 we have to solve. This is the new step. So go to page number 44, IS 800 2007. So their buckling class for the each section they have given, for I section, for channel section, for hollow circular section, angle section, T section, round bar. For each and every section they have given the buckling class. So we have to select the buckling class. So generally here we are using I section. So for I section, how to select buckling class? So for I section, number 1, if you go on the page number 44, please everyone go on the page number 44 IS code. So they have given the table number 10. So first column is cross section. So first is the I section they have given. Second is the limit they have given. Third column is the buckling about axis, and fourth column is the buckling class. See, so for I section, number 1, if H by BF, they have given condition in second column. If H by BF greater than 1.2, if H upon BF value is greater than 1.2 and thickness of flange TF is less than or equal to 40 mm, is less than or equal to 40 mm. See the first row, H by BF greater than 1.5, sorry 1.2 and TF less than 40 mm. Then about, so they have given the axis ZZ there. प्रत्येक जण पाहताय का, पहिला ऍक्सिस त्यांनी झेड दिलेला आहे, पण ऍक्च्युअली तो झेड ऍक्सिस फिगर मध्ये बघा कुठे दाखवलाय. प्लीज एव्हरीवन सी दी फिगर वेअर दे हॅव गिवन झेड ऍक्सिस, की जिथं आपण कायम एक्स ऍक्सिस दाखवतो त्याला त्यांनी झेड ऍक्सिस दाखवलाय आणि वर्टिकल वाय ऍक्सिस आहे. आर यू गेटिंग? सो त्या तो झेड ऍक्सिस म्हटलंय तो ऍक्च्युअली एक्स एक्स ऍक्सिस आहे, त्याला आपण एक्स एक्स म्हणू, आपण एक्स एक्स म्हणतो. आर यू गेटिंग? सो फॉर एक्स एक्स ऍक्सिस buckling class is A and for y axis buckling class is B. This buckling class where we required, हे कुठे लागतात आपल्याला buckling class? FCD ची व्हॅल्यू काढताना आपण टेबल नंबर 9C बघितला आपण, तो बकलिंग क्लास C साठी आहे. टेबल नंबर 9B बकलिंग क्लास B साठी आहे. टेबल नंबर 9A बकलिंग क्लास A साठी आहे. टेबल नंबर 9D buckling class D साठी आहे. So for I section we have to find out this H by BF value. If it is greater than 1.2, then out of these two buckling class we have to use. That how we have to use that we will see. थोडासा कॉलमचा पार्ट डिफिकल्ट आहे, but if we follow the procedure, nothing difficult. So this is the first condition for I section. Again, one more condition is there. Same. If 40 mm is less than TF and TF is less than 100 mm. Then about XX axis buckling class is B and about YY axis buckling class is C. आय सेक्शन मधला सगळ्यात टॉपचा पार्ट झाला बघा. वरचा जो हॉरिझॉन्टल रो आहे तो वरचा हॉरिझॉन्टल रो म्हणजे मी लिहिलेलं सगळं आहे. सो सी पेज नंबर 44 IS कोड. विदाउट IS कोड यू कॅनॉट डू हिअर. IS कोड मध्ये हे दिलेलं आहे. This is the first case for column selection of the buckling class A, B, B, C. So if the condition is this, जर ही कंडिशन असेल H by BF greater than 2, 1.2 and TF less than 40 and TF is less than 100 and greater than 40. So these two condition for X about XX axis and about YY axis A and B class and about XX and YY axis B and C class. So this is the buckling class. This is given on the page number 44. So this is first condition for I section. Now second condition is H by BF is less than 1.2. Here H by BF is greater than 1.2 and here H by BF is less than 1.2 and TF thickness of flange is less than or equal to 100 mm. Then about XX axis buckling class is B and about YY axis buckling class is C. And again if TF is greater than 100 mm, about XX axis buckling class is D and about YY axis also buckling class is D. So that given on the page number 44. Here why we are calculating buckling class? Because the column section is a very long section. So there may be failure due to buckling only. So we have to find here buckling class. Column section having a big length and the column will generally fail due to the buckling only. Buckling म्हणजेच कसं buckling होतं? So like this. This is the buckling. This is the column and buckle. This column will buckle like this. So here we have to know the buckling class for the I section. This I section. Are you getting this? This is for I section. Everyone has written this or it is in on the page number 44. Okay, so this is for now I section. Now for channel section. For channel. See on the page number 44. Where is channel section they have given? Page number 44 IS code. Where the channel is given and for channel which section they have given directly? कोणी सांगू शकते का? पेज नंबर 44 चॅनलचं सिम्बॉल कुठे दिलाय बघा. Anyone can reply me. See the page number 44. Where is channel? In C section. which buckling class they have given for the channel?
C.
बघा लास्ट टून सेकंड रो चॅनल अँगल टी सेक्शन त्यानंतर प्लेट दिलेले आहे सर्क्युलर सेक्शन दिलेलं आहे या सगळ्यासाठी चॅनलला हा सी सेक्शन असतो. सो फॉर चॅनल सेक्शन बकलिंग क्लास इज सी. ऑलवेज फॉर चॅनल सेक्शन बकलिंग क्लास सी. म्हणजे आपल्याला टेबल नंबर 9C ला जावं लागेल. पेज नंबर 42 वरती टेबल नंबर 9C ला जावं लागेल एफसीडी ची व्हॅल्यू फाइंड आउट करताना. हे बकलिंग क्लास कशासाठी लागतंय तो? एफसीडी ची व्हॅल्यू फाइंड आउट करण्यासाठी. पेज नंबर 42 पेज नंबर 43 40 पासून 43 पर्यंत काय दिले बघा. 40 ते 43 या पेज वरती काय दिलेले आहेत? एफसीडी च्या व्हॅल्यू दिलेल्या आहेत. फॉर व्हॉट? ए क्लास, बी क्लास, सी क्लास आणि डी क्लास. पेज नंबर 40 वरती ए क्लास साठी एफसीडी चे व्हॅल्यू दिलेत. पेज नंबर 41 वरती बी क्लास साठी एफसीडी चे व्हॅल्यू दिलेत. पेज नंबर 42 वरती सी क्लास साठी एफसीडी चे व्हॅल्यू दिलेत आणि पेज नंबर 43 ना 43 वरती डी क्लास साठी एफसीडी चे व्हॅल्यू दिलेले आहेत. आपल्याला कॉम्प्रेसिव्ह स्ट्रेस फाइंड आउट करायचे आहे आणि फॉर दॅट वी हॅव टू रिक्वायर दी बकलिंग क्लास. सो फॉर अँगल सेक्शन आपण बघितला बकलिंग क्लास सीच होता, सीच घेत होतो आपण. चॅनलला पण बकलिंग क्लास सीच आहे, फक्त आय सेक्शन साठी बकलिंग क्लास हा चेंज होतोय. त्यानंतर खालचा रो बघा, सगळ्यात शेवटचा रो बिल्टअप कॉलम, की याच्यानंतर आपण जे टाइपचा प्रॉब्लेम बघणार आहे याच्या सिंपल कॉलम नंतर. सो बकलिंग क्लास बिल्टअप सेक्शन साठी सुद्धा बकलिंग क्लास सीच आहे. बिल्टअप सेक्शन सुद्धा बकलिंग बिल्टअप सेक्शन असेल तर म्हणजे बघा दोन आय सेक्शन एकमेकाला जोडले तिथं. सी द फिगर ऑन पेज नंबर 44 लास्ट रो. दोन आय सेक्शन्स एकमेकाला जोडलेले आहेत. दॅट इज नथिंग बट बिल्टअप सेक्शन. अँड फॉर दिस बिल्टअप सेक्शन अगेन सी बकलिंग क्लास दे हॅव गिवन. आर यू गेटिंग? So this is the step number 4. Here we have to select buckling class and for I section we have to buckling class, select buckling class this way. H by BF value we have to calculate. And for column directly we can take buckling class is C. Okay. So here step number 4 is over. Now step number 5. Please follow the procedure only. This is so easy if we follow the procedure. जर तुम्ही प्रोसिजर लिहून नाही घेतली आणि प्रोसिजर प्रमाणे नाही गेला तर काहीही कळणार नाही आणि कोणताच प्रॉब्लेम तुम्ही सॉल्व्ह करू शकणार नाही. These are the procedures we have to follow. Okay. Now next step number 5 is calculate slenderness ratio. Slenderness ratio. So slenderness ratio is nothing but lambda. It is lambda. So how to calculate lambda? Lambda is equal to KL by R minimum. So where KL